So I'm Filip from Biconomy. I'm head of engineering in Biconomy. I want to show you what we offer for today. So first, I want to go from beginning. Biconomy is having 10K prize pool split into two parts. I have compiled a GitHub repo which could be helpful for part one of Biconomy offering, which is the modular execution environment which we can use to build chain abstracted apps. Part two, we only got some helpful resources here, which you can use to build applications for the other part of the prize pool using Biconomy smart accounts, Nexus, smart sessions, and AI agents, which is very cool. I want to start from beginning, actually from the end result of what you could build with Biconomy modular execution environment, just to give you an idea, and then we are going to go through the code a little bit, just so for you to see how easy it is to build a chain abstracted application using our stack. So this is the end result of the small demo application which I have built. This is the application that has been running from this repository, which you should take a look at if you want to build with us. So it's /Biconomy/ETHGlobal-workshop. You literally can clone this repo and then build and run the project to get the same application which I'm showing you right now. What this application is doing, and I'm a Solidity developer, so don't mind this front end here. It's a very simple thing, but I just connected my MetaMask wallet, which is actually this one. And I got myself a generated smart account wallet address, which is generated behind the scenes, doesn't even have to be pre-deployed. And I can use this address using our SDK to build chain abstracted applications. So this example does a cross-chain minting, which means that we have one NFT application, which is deployed on base Sepolia chain, and it accepts USDC for the payment of minting NFTs. But me, here, I have USDC balance on another chain. I don't show it here, but my USDC balance is actually on Sepolia. So what I can do with Biconomy modular execution environment, only on the front-end part, so zero smart contract development involved, I can build a flow that basically bridges funds to base Sepolia chain. If you also have to, you can swap funds and then interacts with any DeFi or NFT or any other smart contract. So all of these steps you define on the front end using our straightforward SDK, and you simply encode these transactions, very straightforward, developer friendly, while the users only have to sign once. They don't even have to have gas. They can see this cross-chain operation getting executed in front of them. I'm going to trigger the cross-chain mint operation right now, which is going to basically in this moment, the front end is defining steps that are supposed to be executed. The steps involve bridging USDC from my home chain, which is Sepolia, using a cross bridge to base Sepolia, where the NFT sits, and it's gonna use those funds then to mint an NFT. So as you can see here, I'm doing an off-chain signature with my MetaMask. This message here is the root super transaction hash. We call these like complex flows, we call them super transactions. You as a developer define them on the front end part, and what you get back from our SDK is one single root hash that the user has to sign, and they're gonna execute their operation. So right now, again, sorry for the front end part here, but I got back the super transaction hash result, which I can open in our Explorer, and I can look up for my transaction with this hash. So this is a many chain transaction, so we can see what's happening here. Basically, I paid for gas fees on Sepolia. That's one user op. Then I bridged funds from Sepolia to base. That's another user op, which just got executed. And now we're waiting for the final user op to be executed, which is like the actual minting of an NFT. So all of this is happening behind the scenes. To the user, you can show just one spinner. You could get like also a feedback from our Explorer as the steps are getting executed. Basically like the best user experience you can ever imagine if you're building anything across multiple chains or multiple DeFi protocols within a single chain or whatever like combination you can come up with. So we are still waiting for funds to arrive at base Sepolia, but as soon as they do, you are going to be able to see the effect of this transaction. Let me go back to this code base for a little bit before the transaction is executed, just to show you how easy it is to use our SDK. So this is like a React application which I have built, which basically contains the code to interact with this NFT contract across many chains. The core part of the process is you should just initialize our SDK using users EOA wallet. Let me show you that part. So this is abstract service. That's what I've called it. Is the service I'm going to call from my application whenever I want to interact across chains. It has this important function which is called init cluster service. Cluster is the old name of our modular execution environment SDK, which you are going to use in this example. We are using it here. So here we initialize cluster. We just give the cluster SDK user's EOA address, which is going to be behind this SDK. And then we can start building these cross-chain flows. For example, this function here, cross-chain mint, what it does is it defines bridging operation and minting operation by a very straightforward procedure. So it's just literally defining user ops and their call data. Very straightforward. If you've ever built a transaction, you know how to do this. Once we've defined the bridge and mint operation, we combine them together into what we call an ITX, or in a new terminology, a super transaction. Here we define steps that we want to see executed, which is bridge and mint in our case. But as I've said, you could put like 20 operations across 10 chains, whatever. And we also define the fee transaction. So what's the fee that the user is using to pay for this whole operation? As I've said, the user doesn't even have to have funds on their EOA. If they got any balance across their smart contracts, which are generated by Cluster, they can use those funds to pay for fees. And again, all of this is happening in just one signature. So once I have built an ITX object, I can literally just fetch the quote from the cluster main instance. And once I get the quote back, I just have to sign once. So the part where I have been signing the off-chain message with my MetaMask, this is like that part of the code right here. Once I sign the message, which is just one off-chain signature, I literally call back cluster.execute again, and we are good to go. This is the part where I got back the result of the operation. The result of the operation was actually the super transaction hash, which basically is not a single chain transaction, it's many chains, so we have to use our own explorer so that we can show you what's happening behind the scenes. One important thing here is that you also should be using some of the bridges available today. Why? Because you need to see funds moving from one chain to another sometimes, and we are not the ones who are providing liquidity. We are just the layer that basically orchestrates transactions across many chains. But you're still going to have to use maybe a cross-chain messaging, depending on your use case, of course, or either a liquidity bridging solution. In our case, we are using a cross. But as I've said, like our stack is unopinionated, so you could use anything. We use a cross because it's fairly quick between different L2s, and we just have to like define a plugin for every bridge we want to use. This is my plugin for a cross bridge. You define this only once, or like if you guys are going to build something and you need a cross plugin, you could just copy paste it from here. This plugin has to be exposed to the cluster SDK so that the cluster SDK knows how to pull funds from many chains to execute the operation on the destination chain. Important part that I have not mentioned here is that cluster SDK is the one who calculates some of these steps when it comes to bridging. Of course, you have to define what you want to do with the funds when they arrive on the destination chain, which is, in our case, is a mint operation. But actual bringing of funds to the destination chain is basically orchestrated by cluster. You can see here that I have just called the encode bridging ops plugin, which we have here defined in our repo. And I just gave it a basic information. Okay, I'm working with USDC. I gave to this plugin something we call token mappings, which is like a list of the same tokens on every chain and their addresses. Like in this case, I have multi-chain USDC, which is a token mapping that defines the addresses of USDC deployments on different chains. So I say to this bridge plugin, I'm working with multi-chain USDC. This is my cluster account. This is how much I want to see landing on the destination chain. This is the bridge plugin, and basically this results here in series of steps that have to be executed to get the liquidity on the destination chain. Then we just combined this with the actual mint operation, because now we know we have at least 2 USDC available on the destination chain. We just bundled this together, and basically that's it. So What can happen here too with the liquidity bridging and encoding steps is that our SDK can figure out that you have liquidity across many chains. For example, you have 5 USDC on Polygon, 5 USDC on Optimism, and you need 10 USDC on Arbitrum. Our SDK is going to encode steps that pull from both chains. You don't have to take care about this as a developer. Let's go back to the actual Explorer. Yes, so now the second user op was executed too. We can go to actual user op Explorer to see what happened here. By the way, this Tenderly debugger and user op Explorer are very useful if you're going to build with this. You could debug your user ops, and because they can sometimes fail, of course. If I bridge 5 USDC, but I want to spend 10 USDC on the destination chain, of course, this second user op is going to fail because there is no funds available for my operation. Yeah, I can see here that I have successfully executed like the final minting transaction. We can copy paste the transaction hash and go to the actual base Sepolia Explorer to see what happened there. So this transaction has in fact paid for the NFT in USDC, and then it received the NFT to its smart account wallet. I could have changed some other operations in this process, maybe send some NFT somewhere else, or literally like anything that comes to your mind probably could be built using this approach. If it involves multiple DeFi protocols, multiple contracts which you need to call in one operation, or even across many chains. We support 8 mainnets and 4 testnets. I suggest using like cheap testnets because Sepolia is very expensive. I just had to pay like 18 USDC, so that's 1/8 for my transaction. That's because that was initial transaction, which also has to deploy a smart account. That's a lazy procedure that happens by default once the users interact with our stack for the first time. Okay, going back to the actual repo. Here I have tried to explain on how to clone this repo, how to spin this project, which you have just seen in action. This is cross-chain minting of NFTs. And you could reproduce like the whole application. You could get it live and running. You could actually test the cross-chain minting stuff. I also got some useful information here on what your environment should look like if you are going to use the MEE or cluster SDK, which is the old name for our stack. And there's also some useful resources here. You're going to have to probably use USDC faucet. So USDC has an official, so that's by Circle, right? They have the official faucet that you could use to get some USDC funds on testnet. I have used this, for example, for today to obtain some USDC to test my flow. There is our full zero to hero guide, which explains step by step how to build an application using our chain abstraction stack. Then there is the Explorer, which I have just showed you. This is where you go to see what's happening between chains. Then you have the node info. This is something I haven't opened, but we are running our public node. So cluster or modular execution environment is actually a network of nodes which provide this service of executing transactions for you as a developer and for user who's using your app across many different chains. So here, of course, you could see like all the chains we support in the node info, and also all the tokens that are accepted by the node per every chain for gas payment. You could see that there's stablecoins here, wrapped Ether, and stuff like that. Finally, we do not have this exposed in our SDK yet, but you as a good developer would like to show to the user steps that are happening as they are executing in real time. So here I've put the direct link to our API of the Explorer that you could be using to fetch the details of one complex cross-chain action. So here we see how that looks like. You're going to figure it out very soon. It's just /explorer/super transaction hash. That's the hash that you receive back when the user actually executes the super transaction. And this is something that you could use to track the status of every user op as they're getting executed. See here, there's a list of user ops. It's always going to contain a status. Right now it's success with transaction hash, but this here could be pending for every user op initially, and then as the user ops are getting executed, you could be seeing different results here. You would have to poll this URL, right? Okay, back to repo again for one last thing. So this is half the price that we in Biconomy offer is for chain abstraction applications using this cluster SDK. And this is a good start here, this repo, so this ETHGlobal workshop. There is the part 2, which is another half of the price, goes to the actual Biconomy SDK, which you would use basically to create, for example, AI agents that interact with Biconomy smart accounts. And basically, there is a piece of the price for AI agents and piece of the price for usage of smart sessions, which is the latest thing we released in the world of smart accounts. A very powerful module which you could be using to build like cool applications powered by smart accounts. Finally, we will be offering developer support. This is our public group, Biconomy Builders Group, where you could just like reach out to us. We are not going to help you to build your application and win the prize, but we will help you if like you have like a huge console stack trace and a bunch of red lines. We might be able to help you with that, of course. You could just join using this link. This is a Telegram group, and we would be very willing to help you. Yes, that's it from me. We got 2 more minutes left. If there is any questions, I tried to spare 2 minutes, so let me know. Yeah? Can you just, yeah.
I saw that you made the user sign a blind hash. Is it possible to do that also with a more like with a type, for example, signature, or not?
So it's always one root hash.
Always a root.
It's always a root super transaction hash. So all the operations that are bundled inside a super transaction are described by this one hash that the user has to sign, and that's basically it. That's like one off-chain signature. You would be, for example, using a VM, which I was using in this repo, to just initiate like a signed message call on the user's EOA. And you would literally provide the VM with the sign message function with this root transaction hash, and that's it. Yeah. Anyone else? Yeah.
Can super transactions fail mid-flight?
If the transaction, what happens if the transactions fail in the process?
Yeah.
The UX gets impaired a little bit because, like, let's say you defined an operation that bridges 10 USDC to chain B from chain A, and then you try to on chain B you try to buy something for 20 USDC. This is a developer error because the user ops were not defined properly. So what's going to happen is 10 USDC is going to get bridged, but the destination chain operation is going to fail after some time. Our nodes are going to wait for some time to see if there is going to be any moment when the transaction is going to succeed. If not, they're just going to execute the transaction with status fail, which is what you are going to be able to get on our API for the Explorer. Yeah. All right, guys, thanks for listening. And I'm going to be at Biconomy's booth on that opposite side where all the booths are. If you want to ask me something, come stop by. Feel free to talk to me. Thanks, guys.